Hello everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is the Pure Mathematics 1 for May-June 2019, and the code is 9709/12. So let's move on to question number 1. So for question number 1, find the coefficient of x in the expansion of degree 5 of 2 over x minus 3x. Okay, so first of all, I will rewrite the question. Now, for your information, the binomial expansion formula is summation r from 0 to n, CR, a to the power of r, b to the power of n minus r. Okay, for a plus b to the power of n. So now from here, to apply this formula, make sure it is a plus. Therefore, now you are given a minus. Then I will be changing this into 2 over x plus negative 3x, then to the power of 5. That means now when you compare, my a is 2 over x and the b is minus 3x. Alright, then now use this formula. It will be summation r from 0 to 5, then 5CR. Okay, probably. So I will write in this form, 5CR, then first term to the power of r, second term to the power of 5 minus r. Then from here, I will split the terms. So that means you are getting 5CR to the power of r, because we have a formula here. So a over b to the power of m, that is a power m over b power m. Okay, so it means that the power can be brought inside, right? So which means now here I supposed to get 1 over x to the power of r, but then the 1 over x is actually x power negative 1. Okay, so for the minus 3, I will write to the power of 5 minus r and then x to the power of 5 minus r. And now you need to get coefficient for x. That means now here I will just write x is x degree 1. Therefore, I need to find out the r. Then I will just consider the terms with the x. Alright, then from here you will be getting x to the power of minus 1 times r multiply with x to the power of 5 minus r. Now, this r can be brought inside. That means I'll get x power negative r times x to the power of 5 minus r, because we have a formula. So the formula is a to the power of m, then another power n outside. This is basically a to the power of mn. Okay, and now for this step, to simplify it, we have another formula, which is a to the power of m times a to the power of n equals to a to the power of m plus n. That is the same base. When you multiply same base, we are adding the degrees. That means now basically I'm getting x to the power of minus r plus 5 minus r. Okay, and it is same as x degree 1. Then from here, I will just compare the powers of x from both sides. So left side 1, right side minus r plus 5 minus r. Therefore, you are getting 5 minus 2r equals to 1. Hence, my 2r, okay, will be moved to the other side, and this 1 will be moved to right side. So here I will be getting 5 minus 1, which is 4. Hence, my r is 4 over 2, that is 2. That means now my coefficient of x exists when the r is 2. So now my coefficients will be all these remaining terms. All this will be the coefficients of x, right? So now I will just write down coefficient of x. That is 5c2, 2 to the power of 2, because the r is 2, then minus 3 to the power of 5 minus 2. That means here it's going to be 10 times 4 times minus 27. And at last, you are getting negative 1080. So that is the solution of this question. Now, for question number 2, 2 points A and B have coordinates 1, 3 and 9, -1 respectively. The perpendicular bisector of AB intersects the y-axis at the point C. Find the coordinates of C. Okay, now, basically, let's say this is, okay, 1, 3, and 9 minus 1. So here are the 2 points. Perpendicular bisector of AB means that you need to bisect the AB, means you need to find the midpoints, and make sure it is perpendicular. So here is 90 degrees. This is the line. This is the perpendicular bisector of AB. Okay, and then intersects the y-axis at point C. So when intersect the y-axis means that the x equals to 0. Okay, so obviously your C has x equals to 0. Then now what I need to do is, firstly I find the midpoint of AB. So my A with coordinates 1, 3, my B is 9 minus 1. So for the midpoint is basically average midpoint of AB. That is the average of the x and also average of the y. So 1 plus 9 divided by 2 for the x coordinates, and then 3 plus minus 1 over 2. So from here, you will be getting 10 over 2, and then 2 over 2, and this is going to be 5, 1. That is the midpoint of AB. And then now here, since it is perpendicular, the orange line is perpendicular to the blue line, means that now I need to calculate the gradients of AB. So now, MAB, gradients of AB, our formula is, let's say here A, x1, y1, B is with coordinates x2, y2. The M is basically the difference of y over difference of x. Alright, so now just apply this formula. I will be getting 3 minus 1 over 1 minus 9. So numerator is 4, denominator is minus 8. Therefore, I'm getting negative half. And now, when you refer to the diagram, we are finding the orange line, which is perpendicular to the AB, which means now M prime times MAB is minus 1. Therefore, my M prime is negative 1 over MAB. Okay, that is negative 1 over MAB is negative half. And hence, you are getting 2. So now, the perpendicular bisector. So I will write equation of the perpendicular bisector of AB. That is y minus y1 equals to m bracket x minus x1. Okay, so now for this, I will be using this gradient and also the midpoint of AB. Okay, so then here I will write y minus, my y1 is 1, the m is 2, then x minus 5. Then from here, y equals to, now do expansion for the right side first. It will be 2x minus 10, 2 times 5 is 10, and then move this minus 1 to the right side, so it becomes plus 1. Therefore, your y equals to 2x minus 9. This is the perpendicular bisector. But then, when you refer to the question, it's mentioned that the perpendicular bisector of the line intersects y-axis at point C. So, intersect y-axis, that means x equals to 0. Then I need to find out what is the y coordinate. So now, I was just write at C, the x equals to 0. Therefore, now my y is 2 times 0 minus 9. That is going to be minus 9. Hence, my point C with coordinates 0, minus 9. So that is the solution of this question. Okay, now, question number 3. The curve is such that dy dx is this expression, and then the points P with coordinates 2, 9 lies on the curve. First part, a point moves on the curve in such a way that the x-coordinate is decreasing at a constant rate of 0.05 units per second. Now, this means whenever you see rate, that is d over dt. And now this rate is referring to the x-coordinate, therefore dx dt, and the value is 0.05. But now, be careful with this, it's mentioned decreasing. So when decreasing, that is a negative. Okay, there's a negative sign. But when you forgot to write the negative sign, then it will be increasing. So now you need to calculate the rate of change of the y when the point is at P. So that means it's at this. Right? Basically, you are given dx dt is negative 0.05. And then you are given dy dx, right? X cubed minus 4 over x squared. And now you need to find what is your dy dt. So now, I will just calculate, because you need to find the rate of change, the dy dt at points P. So I will just calculate what is my dy dx at the points P. So at P, 2, 9, my dy over dx is basically, x is 2. So 2 cubed minus 4 over 2 squared. That means you will be getting 8 minus 4 over 4 is 1. That is 7. Okay, so now my dy over dt equals to dy over dx. This is a chain rule times dx over dt. So my dy dx is getting is 7. Dx dt is given, so negative 0.05. And then here I will be getting negative 0.35. Then this is units per second. That means you can say that the y is decreasing. At rate of 0.35 units per second. Because of negative, then it's decreasing. Okay, now part 2, find the equation of the curve. So for your information, if you are given y, when you differentiate, you will be getting dy dx. But then, when you are given dy dx, to get the y, that is the reverse process, which is the integration. Right? So now, I will copy my dy dx, x cubed minus 4 over x squared. And now to integrate, I will move up the x squared. So this one becomes x cubed minus 4x to the power of negative 2. And now to get the y, I will just do the integration on these two terms. And now for your information, to integrate x degree n dx, the formula is x to the power of n plus 1 over n plus 1, then plus c. And this formula is valid when the n is not minus 1. Otherwise, the denominator will be 0. So now here, I will get x degree 4 over 4 minus 4. Now, x degree negative 2. When you plus 1 to negative 2, that is minus 1. Then over the new degree, followed by plus c. And now here, I will simplify. This is x degree 4 over 4. Now, look at here. Minus minus is a plus. And I will be getting 4. Then this term is x degree negative 1. Whenever you see negative degree, you can just move it down to be the denominator. Therefore, I will be getting plus 4 over x, then plus c. Now, to get the c, we need the values of x and y. So look at the question. You are given the point P29. Okay, then now just replace these coordinates into the curve equation. So it means that now 2, 9, that means your x is 2, your y is 9. Therefore, I will get 9 equals to 2 to the power 4 over 4 plus 4 divided by 2, then plus c. So 2 to the power 4 over 4 is basically 4. Okay, because 2 power 4 is 16. So here I will be getting 4 plus 4 over 2 is 2, then plus c equals to 9. Therefore, your c is 3. And now just rewrite. That will be your equation of the curve. Okay, so done for this question. Now for question number 4, angle x is such that sine x equals to a plus b, cos x equals to a minus b. Show that a squared plus b squared has a constant value for all values of x. So now from here, I will rewrite sine x is a plus b, then cos x is a minus b. Now, to get a squared plus b squared, okay, so from here, let it be first equation, second equation. Now, to eliminate the unknown, the a or b, okay, so since here I get 1a both sides, I mean from both equations, and then minus plus b and minus b from both equations, so I will just add up two equations. So when I add up two equations, basically left side it will be sine x plus cos x. Then right hand side a plus a is 2a. Then the plus b plus minus b it will be 0. Then from here I get my a equals to half of sine x plus cos x. Okay, so I have found the a. Now to get the b, just now I used plus, now I will be using minus because I need to keep my b now to eliminate the a. So I will write first minus second. So therefore, sine x minus cos x. Now a minus a on the first term on the right side, it will be 0. Then for the second term on the right side, b minus minus b, that is 2b. That means my b is half of sine x minus cos x. And then now I will substitute into a squared plus b squared. So a squared plus b squared, that is half bracket sine x plus cos x. Then you square it and plus with half times sine x minus cos x, all these terms squared again. So then from here, you will be getting, right, 1 over 4, because the square must be bring inside the bracket, bring into the bracket. So here will be 1 over 4, because half of square of half is 1 over 4. Then here I will be getting sine x plus cos x squared. Same goes to the second bracket. This is 1 over 4 sine x minus cos x squared. And then now just do expansion. Refer to the quadratic expansion. Okay, a plus b squared. This is going to be a squared plus 2ab plus b squared. That means you will be getting 1 over 4. Then sine square x plus 2 sine x cos x plus cos square x. That is from the first expansion. Now plus with the next expansion, it will be sine square x minus 2 sine x cos x. Now minus, even though here minus, right, here minus, but the last term is still plus. Therefore, I will get plus cos square x. Now I notice that both also with 1 over 4, so I can just take out the 1 over 4 and open the brackets. So when I open the brackets, it's basically sine square x plus 2 sine x cos x plus cos square x from the first bracket, and then because of here is plus, so this plus you times inside the bracket. So it will be plus sine square x minus 2 sine x cos x, then plus cos square x for the last term. Okay, then from here, you can cancel off the 2 sine x cos x, because one is plus, one is minus. And now here, sine square x, right? Or probably you can say sine square x plus cos square x is basically 1. Then here is another 1. Therefore, I will get 2. So this is 1 over 4 times 2, which is half. Okay, because Sine square x plus cos square x equals to 1. Right? So these two together is 1. Right? So that's all for this question. So that's why in the question is mentioned that has a constant value for all x. That is the solution. Now, part 2. In the case where tangent x equals to 2, express a in terms of b. So now, we know that tangent x is basically sine x over cos x. Then from here, alright, sine x over cos x. So now here, my sine x is a plus b, cos x is a minus b. So I will just substitute these two expressions. So a plus b over a minus b equals to 2. And now you need to find a in terms of b. That means just move up this whole term. Then I will be getting a plus b equals to 2 of a minus b. Then just do expansion for right side. 2a minus 2b equals to a plus b. Then now to get the a in terms of b, okay, so the a will be moved to one side, and then the b will be moved to the other side. That means now here, when I move the a to right side, it will be minus a. So 2a minus a is 1a. Then the minus 2b moved to the left side, it will be plus 2b. So end up with 3b. So that means a equals to 3b. Okay, now for question number 5. The diagram shows a semicircle with diameter AB. That means OA is R. Okay, center O and radius R, because OB is R. Now, the point C lies on the circumference and angle AOC is theta, is given on the diagram. The perimeter of sector BOC perimeter means all these lengths, right, is twice the perimeter of AOC, the small sector. Find theta correct to two significant figures. So now from here, I know that angle AOC is is theta. So angle COB, it will be pi minus theta, because one line is pi. So here I found that this is basically pi minus theta. And then since the O is a center, that means the OC is also radius R. So now perimeter of sector BOC is twice perimeter of sector AOC. Okay, which means, now for your information, the perimeter is OB plus OC plus the arc length. Okay, just for your information, let's say this is the sector. Here is theta, this is R. This arc length, alright, this arc length formula is theta R. So from here, I know that my perimeter of the BOC is basically OB is R, so R plus OC, also R, then plus the angle is pi minus theta times the R, which is double of perimeter of sector AOC. OA is R, OC is R, then this length is theta R, because the angle is theta. So I will just write R plus theta R. And now we need to get the theta correct to two significant figures. So now for the left hand side, 2R plus, now do expansion. Okay, then here is going to be pi R minus theta R. Now for the right side is 2 of 2R plus theta R. Okay, or probably I can just times directly. So this is 2R, this is 2R. 2R times 2, 4R. Okay, then these two multiply to theta R as well. So you will be getting plus 2 theta R. And now to get the theta, Therefore, data must be the subject, which means all the terms with the data must be on one side, and then without the data will be moved to the other side. So now here I will be getting 2 data r plus data r. Okay, then now when I move the 4r to the other side, is basically 2r plus pi r minus 4r. Then from here you will be getting data. Now you combine. For the left hand side, 2 data r plus data r is 3 data r. Okay, for the right hand side, 2r minus 4r is minus 2r. So I will write pi r minus 2r. Right, so now all the r can be cancelled off. So just cancel the r from all the terms. That means now I'm getting 3 data equals to pi minus 2. And now my data just divide by 3. So 1 over 3 times pi over 2. And now calculate this using calculator. That is going to be 0.38, 2 significant figures as requested in the question. So this is basically radians. Okay, now for question number 6, the equation of a curve is y equals to 3 cos 2x, and the equation of a line is this. Now first part, state the smallest and largest values of y for both the curve and the line for x between 0 and 2 pi. Okay, now for y equals to 3 cos 2x, now when x between 0 and 2 pi, we know that cos x or cos 2x, right, is between 1 and minus 1. Therefore, 3 cos 2x will be between 3 and minus 3. Okay, so from here, my smallest y is minus 3, and my largest y will be positive 3. That is for the first graph. Now for the second one, which is the line. So 2y plus 3x over pi equals to 5. So here I will get the y as a subject. So it means that my y is basically move this to the right side. So 5 minus 3x over pi, and then followed by dividing 2. So times half. Okay, so now your largest is 2 pi for the x. Alright, so now I will just substitute. So from here, when x equals to 2 pi, my y will be 1 over 2 of 5 minus 3 of 2 pi over pi. So now the pi will be cancelled off. So that means 5 minus 6, right? So 5 minus 6 is basically minus 1. So I will be getting minus half. Then when x equals to 0, 0 is the smallest x. So y equals to half, because this is a straight line. So that's why we just substitute the lowest and the greatest value of x. That will be the lowest, smallest, and largest y value for the straight line. So here 5 minus 0, that is 5 over 2. So from here I will say largest, or I will write smallest first, smallest y equals to negative half, and then largest y, that is 5 over 2. Okay, so done for this question. Now part 2, sketch on the same diagram 2 graphs for x from 0 to 2 pi. So from here, I will just sketch first, right? Now look at the curve. Smallest minus 3, largest 3. Okay, then the straight line, smallest negative half, largest 5/2. So it means that I need to draw my y-axis to include up to positive and minus 3. Let's say here 1, 2, 3. Then here is 0, minus 1, minus 2, minus 3. This is, okay, now we are sketch. Since it is cos 2 pi, cos 2x, just for information, if let's say you are sketching y equals to cos x, it is like this, right? But since cos 2x means that you have to repeat this for 2 times because that is the frequency. So what I need to do here is probably I will just sketch first. That will be easier for me to label. This is cos 1x, then cos 2x. Okay, so just repeat this for 2 times. Then now I will label. This is my 2 pi. So half of the graph, here is pi. And then another half of the first part, this is pi/2. Here is 3/2 pi. Alright, because for the original graph, this is basically 2 pi here. And then here is pi. This is pi/2. And maximum 1, minimum minus 1. That is the original graph. I mean the cos 1x. This is 3 pi/2. Okay, so now here I will label. This is y equals to 3 cos 2x. And now to sketch this line will have a minimum. I mean you will have a negative gradient because of negative over here. Maximum is 5/2, minimum negative half. So just mark. And the minimum happens at x equals to 0. Sorry, the negative half, your y equals to negative half when the x is 2 pi. So 2 pi negative half. Alright? And then when x 0, your y is 5/2. 5/2 is 2.5. So 2.5. So now join these 2 points using ruler. Okay, here I will just simply join. Right. Okay, so roughly here. Right? Okay, so here, negative half. So this green line is basically 2y plus 3x over pi equals to 5. Okay, so done for the sketching. Now, part 3, state the number of solutions of the equation 6 cos 2 pi minus 5 minus equals to 5 minus 3x over pi for this x. Okay, just now we have y equals to 3 cos 2x. So y1 equals to 3 cos 2x. Your y2, 2y plus 3x. Okay, so probably I will just write 2y plus 3x over pi equals to 5. So if I substitute first equation into second equation, that means I eliminate the y because I want to get this relationship, okay, or this equation. So then from here, first into second, which means 2 of 3 cos 2x plus 3x over pi equals to 5. That means here I will get 6 cos 2x, right? Then this term will be moved to right side. So I will be getting the same equation over here. That is 5 minus 3x over pi. That means this equation actually is referring to the intersection points. Okay, so because when I substitute first equation into second equation means that I'm solving simultaneous equations, which will be giving you the intersection points. That's why you need to get the intersection points. How many? Okay, state the number of solutions, means how many intersection points from the graph. So obviously 1, 2, 3, 4. So it will be 4 intersection points. So then you can just write 4 solutions. Okay, so that's all for this solution. Now for question number 7, given two functions fx and gx, fx is defined for real number of x and the gx also real numbers of x except 1. So first part, obtain expressions for f inverse and g inverse, stating the x values for which g inverse is not defined. So to get the inverse function, we will define the function as y first. So let y equals to fx. Therefore, y equals to 3x minus 2. Now you get the x as a subject. So now 3x equals to y plus 2. Therefore, your x is y plus 2 divided by 3. This is f inverse. Okay, now on the other hand, let y equals to gx. So now my y equals to 2x plus 3 over x minus 1. And now we need to get the x as a subject, means that I have to move up the x and combine with the y. So it's like y times x minus 1 equals to 2x plus 3. And do expansion for the left hand side. So yx minus y equals to 2x plus 3. And now to get the x, just combine or just group the terms with the x. Okay, or probably I can just move the 2x to the other side, so that the minus y move to the right side, it will be positive. So then from here, I will get yx minus 2x equals to 3 plus y. And then now for the left side, the x is in common. Factorize the x to get x times y minus 2, then equals to 3 plus y. So here your x will be 3 plus y over y minus 2. And now from here, just change the x into g inverse. Then I will be, and on the right side, the y will be changed to x. So it will be 3 plus x over x minus 2. So that will be the expression for g inverse. And now last part, state the x for which g inverse is not defined. So g inverse is not defined when the denominator is 0. Alright, so I will just write g inverse is not defined when x minus 2 equals to 0. That means your x is 2. Okay, so that is the solution of this question. Now part 2, solve the equation f gx equals to 7 over 3. The f gx is basically the composite function. So now I will rewrite my fx equals to 3x minus 2 then my gx equals to 2x plus 3 over x minus 1. Now the fgx is basically f of gx. That means now I will replace my gx first. That is 2x plus 3 over x minus 1. And now this means the x in your original fx will be replaced by this rational function. That means here I will be getting 3 of the rational function, then minus 2. So here is going to be 3 of the rational function, then minus 2. Okay, and now I will do expansion. Okay, so basically you can just write in this form first. No need to simplify because our purpose is to solve this equation. And now I have found the fgx. So now I will just substitute this function into the equation. So fgx equals to 7/3. Right. So here is going to be 3 times 2x plus 3 over x minus 1. Then minus 2 equals to the fraction. Now, I can just move this minus 2 to the other side, becomes plus. So here I will be getting this whole term. Now 7/3 plus 2, that is 13/3. Okay, now to get the x, the 3 will move to the other side first, or probably you can just do cross multiplication. This 3, you move up. This x minus 1, you move to the other side. Okay, so here you will be getting 9 times 2x plus 3 equals to 13 times x minus 1. And now do expansion, because the question says solve. Solve means find the unknown in the equation. So here when I do expansion, just multiply. The left hand side, it will be 18x plus 27. Right hand side is going to be 13x minus 13. And then now group the x on left side and the numbers on the other side. So that means I will be getting 5x, because when you move the 13 to the other side, it becomes minus 13. Then right side will be negative 13 minus 27. That is going to be negative 40. Therefore, my x is minus 40/5. That is minus 8. Okay, next question, number 8. The position vectors of A and B are given. Find the K for which the angle AOB is 90 degrees. So for information, if AOB is 90 degrees, so here A, this is O, here is B, 90 degrees, which means OA dot OB equals to 0. Okay, so we need to refer to the dot product or scalar product. So I will start with OA dot OB equals to 0. Then now, the OA, 6 minus 2 minus 6 dot 3k minus 3 equals to 0. So for the dots products, the calculation is you just multiply each component and plus all 3 together. So then I will get 6 times 3 plus negative 2 times k plus minus 6 times minus 3 equals to 0. Then from here I will get 18 minus 2k plus 18 equals to 0. The minus 2k will be moved to the other side. So then I will write the 2k first. 18 plus 18 is 36. Therefore my k is 18. Now part 2. Find the values of k. Values means more than 1k, for which the lengths of OA and OB are equal. Okay, so OA, write down the vectors first. 6 minus 2 minus 6. Then OB, 3k minus 3. Okay, now length means magnitude. So magnitude OA, or probably you can just write OA, no problem. It will be square of sum of square of each components. That means it's 6 square plus minus 2 square plus minus 6 squared. And this is square root of 76. Okay, then magnitude of OB, vector OB, that is OB, same as square root of 3 square plus k square plus negative 3 squared. That means this is 3 squared is 9. 9 plus 9, 18. So 18 plus k squared. And now mention that they are equal. So now I will write square root 76 equals to square root of 18 plus k squared. So now you square both sides. So square and square root cancel off. Therefore, left hand side is 76, right hand side 18 plus k squared. So your k squared is 76 minus 18. That is going to be 58. Then your k will be plus minus square root 58, right? So find the values of k. So let me check whether I can simplify the square root 58. Oh, square root 58 is the simplest form, so cannot be factorized. Okay, so done for this second part. Now, the point C is such that vector AC is 2 vector CB. In the case where k equals to 4, find the units vector in the direction of OC. Units vector is basically a vector with magnitude of 1. Okay, so units vector, let's say unit vector of A, that is vector A divided by its magnitude. So I need to get OC first before I get the units vector and replace the k by 4. So when the k by 4, okay, when the k is 4, so now my OA is 6 minus 2 minus 6. And then my OB, 3k minus 3. So now my k will be replaced by 4. That means I'm getting 3, 4 minus 3. Okay, so now substitute into this equation. So AC equals to 2CB. AC is OC minus OA. Then CB is OB minus OC. Okay, now here we need to find the OC. That means I will do expansion for right side. And then the OC will be grouped together. So it means that this minus 2OC will be moved to the left side, and this minus OA will be moved to the right side. That means now I will be getting 3OC equals to 2OB plus OA. Okay, then now my OC is basically 2 over 3 OB. You just divide by 3 plus 1 over 3 OA. So now substitute into the OB and OA over here. So then I will get 2 over 3 times 6 minus 2 minus 6. Oh, sorry, this is B. Oh, the B is 3, 4 minus 3. Then plus 1 over 3 of 6 minus 2 minus 6. So when you times, right, 2 over 3 times 3 plus 1 over 3 times 6. So basically you are getting 4, 2, and minus 4. So that is your vector OC. But then the question is asking for units vector in the direction of OC. That means now I need to find the magnitude of the OC. So magnitude of OC is basically square root of 4 squared plus 2 squared plus minus 4 squared. Then this is going to be square root of 36, which is 6. So now my unit vector of OC, that is OC divided by its magnitude, which is 1 over 6 times, okay, actually it's divided by 6, but then instead of writing divide by 6, it's same as times 1 over 6 of 4, 2 minus 4. Therefore, times in, right, or probably you can just factorize the 2 from the bracket, from the vector. I will be getting, okay, let's say I show step by step working. This is going to be 1 over 6 factorize 2, then it will be 2, 1, negative 2. So the 1 over 6 and 2 can be simplified into 1 over 3. So then you can just write your answer in this form. 1 over 3 of 2, 1, negative 2. So that is your vector, unit vector of OC. Okay, now next question, number 9. The curve C1 has equation y equals to x squared minus 4x plus 7, and then the C2 has y squared equals to 4x plus k, where k is constant. The tangent to C1, tangent means dy dx, right? At the point where x equals to 3 is also the tangent to C2 at the point P. Find the k and the P. So firstly, we know that tangent to C1. So tangent means the gradient is dy dx. Alright? So where x equals to 3. So now I will write C1, this is C1, y equals to x squared minus 4x plus 7. Then now my dy dx, there is a gradient of tangent. This is gradient of tangent. That is 2x minus 4. Because when you differentiate x degree n, that is nx n minus 1. Okay, then from here, I know that at x equals to 3. So when x equals to 3, dy over dx is 2 times 3 minus 4. That is 6 minus 4, then I get 2. Right, now the tangent to C1 at the point where x equals to 3 is also tangent to C2. So now I need to find out the tangent first. So equation of tangent, but then I do not know what is the coordinate. I need to find out what is the y coordinate. So x equals to 3, your y is 3 squared minus 4 times 3 plus 7. That is going to be 4. So I know that there is a point with coordinates 3, 4. Okay, and now the tangent to C1. So means that now I need to find out what is the equation of tangent to C1 at 3, 4. So use the formula y minus y1 is m of x minus x1. So now my m is basically dy dx because there is a gradient of tangent. So here is going to be y minus 4 equals to 2 of x minus 3. Then you will be getting y minus 4 equals to 2x minus 6. So your y is 2x minus 6 plus 4. That is y equals to 2x minus 2. This is the equation of tangent to C1. And then when you read the question carefully, this tangent is also the tangent to C2 at point P, which means, right, let's say this is the tangent to C1, right? And then this is also tangent to the another curve. That means, right, let's say this is the first curve, this is the second curve. So that is the intersection point, right? So now I will say here my C2. So my C2, I just copy y squared equals to 4x plus k. Let this be the second equation. Because when you refer to this diagram, okay, as I've shown here, curve 1, okay, this is a curve 1, quadratic. Another curve, let's say something like that. Okay, so now the tangent. So I will just simply sketch. Let's say okay, let's say just an example. Okay, let's say just an example. So this tangent is a tangent to this point, to this curve, and also tangent to another curve. That means this is not the actual graph. Okay, so now what you need to know is see, basically the graph is like that, another one is like this, right? So because it's mentioned tangent, so probably like this. Okay, so then you need to find out the intersection point. Means that this line is also the tangent of the curve. So whenever tangent means that they will be touching, the straight line will be touching the curve at one point. So now I need to solve the simultaneous equations. So therefore I let this equation be 1. Alright, so now I will just find the intersection points between first and second equation. So I will substitute first into second equation. So now my y is basically 2x minus 2. So here I will write 2x minus 2 squared equals to 4x plus k. Because now you need to find the k and also the coordinates of points P. Then from here, I will expand the left hand side. So and again, a minus b squared, that is a squared minus 2ab plus b squared. Therefore, you are getting 4x squared minus 8x plus 4. That equals to 4x plus k. So move all the terms to the left hand side to get a quadratic equation. That means now here I will be getting 4x squared minus 8x plus 4 minus 4x minus k equals to 0. Then you will be getting 4x squared. And now when you simplify minus 8x minus 4x, it will be minus 12x. And then the 4 and minus k combine to be the constant. Okay, so this equation will give you the intersection points between the tangent line, which is the first equation, and the C2, right? So then from here, since we know that the tangent to C1 is also the tangent to C2, that means there will be just one equal real root when you solve this quadratic equation, meaning to say that my discriminant equals to 0, right? Because there's only one real root. So I write down all the coefficients first. So now my discriminant equals to 0. That means b squared minus 4ac equals to 0. It is equals to 0 because straight line is the tangent to the curve. So they will be touching at one point. So then from here, I will get negative 12 squared minus 4a. My c is 4 minus k equals to 0. Then now here you just do expansion. Square of minus 12 is 144. So here, 4 times 4 is 16. So minus 16 times 4. That is minus 64. Then minus 16 times minus k. That is plus 16k. Alright. Then from here, you will just solve the k. So now my 16k, okay, then these two values will be moved to the other side. So you will be getting minus 80. Therefore, your k is minus 80 over 16. That is minus 5. So we found the k, and now you need to find the p. Okay, so the p is actually the point when k equals to minus 5. Therefore, I will just substitute the k value into this equation. Okay, so I will let this be my third equation because the tangent line is, the straight line is a tangent to C1, C2 at points P. That means there is an intersection point. So equation 3 is giving you the intersection points between the straight line and also the C2. Okay, so I will write here from third equation where k equals to minus 4. So I will get 4x squared minus 12x plus 4, where k equals to minus 5, where k equals to minus 5. So 4 minus 5, then equals to 0. That means from here, you will be getting 4x squared minus 12x. 4 minus minus 5 is basically plus 9. Okay, and then this quadratic equation can be factorized. So to get 4x squared, it will be 2x times 2x. Then you look at the sign here. This is minus. We know that minus minus is a plus. So it means that both sign must be minus. So to get 12 from the multiplication, we know that the 9, right, is actually 9 times 1 or 3 times 3. So to get negative 12x in the middle term later on, I will just write 3. So that when you multiply these two terms, that is minus 6x for both. And then your final answer, you multiply the first column and multiply the third column. Middle column you plus, right? That is negative 12x. So from here, your factors will be cross multiplication. So this is the manual factorization. Okay, or otherwise you can just use a calculator to get the roots. So I will get 2x minus 3 squared equals to 0. Therefore, 2x minus 3 equals to 0. Hence, 2x equals to 3. And then your x equals to 3 over 2. So this is the x coordinate of the points P. Now, the points P, okay, so this points P is on the C2 and also on the tangent line. So I can just substitute this x into the first equation or the second equation. So it's up to you. So I will just substitute into first equation. So y equals to 2 times 3 over 2 minus 2. So then from here, the 2.5 will be cancelled off. At last, you are getting 1. That means now my points P actually with coordinates 3 over 2 and 1. Okay, so done for this question. So for question number 10, A, in an arithmetic progression, the sum of the first 10 terms is equal to the sum of the next 5 terms. The first term is A. First part, show that the common difference of this progression is 1 over 3A. Okay, first term is A. The common difference, let it be D first. Right? And now it's mentioned that sum of the first 10 terms, so S10 equals to sum of the next 5 terms. Okay, now let's see here. T1 until T10. We plus all together, that is S10. Then now, the next 5 terms, probably it will be T11, T11, T12, T13, T14, T15. So, sum of these next 5 terms, but you must remember that whenever you use Sn, it must be counted from the first term. So that means if I need to get just the green color, all this, right, it will be S15 minus S10. That will be sum of the next 5 terms. Okay, so that's why here I will write this is same as S15 minus S10. Okay, then now the minus S10 will be moved to the other side. So on other words, I'm getting S10 plus S10, which is 2S10 equals to S15. And then now for arithmetic progression, Sn is n over 2 bracket 2a plus n minus 1 d. So whereby the d is a common difference. Okay, so here I should write common difference d. So now just substitute into the formula. It will be 2 of 10 over 2. Then 2a plus n minus 1. N minus 1 is 9. Then d equals to S15 is 15 over 2. 2a plus 14d. Okay, so on the left hand side, the 2.5 can be cancelled off, and then this 10 times into the bracket, right? And then this, for the right hand side, the 2 and 2a can be cancelled off, then 2 and 14, it will be 7. So it means that now here, actually I'm getting 20a plus 90d equals to 15a, then 15 times 7, that is 105d. Then now, you need to show a common difference, which is the d, equals to 1 over 3a. So it means that I will move the d to one side and then the a to the other side. So which means I'm getting 105d minus 90d equals to 20a minus 15a. So for the left hand side, you will be getting 15d. For the right hand side is 5a. So from here, my d is 5 over 15a, which is 1 over 3a. So I have shown the common difference. Now, part 2, given that the 10th term is 36 more than the 4th term, find the value of a. 10th term is 36 more than 4th term. That means T10 minus T4 is 36. So now our nth term Tn is a plus n minus 1 d. So from here I will get a plus 9d minus a plus 3d equals to 36, right? Then from here, when you open the bracket, a plus 9d minus a minus 3d is 36. So when you look at here, the a and minus a will be cancelled off. So just left 9d minus 3d, that is 6d equals to 36, which means now my d is 36 over 6, that is 6. And now you need to find a. So then to get the a, refer to the previous part, the part a. d is 1 over 3a. So then from here, I will just write from first part, d is 1 over 3a. That means now 6 is 1 over 3a. Therefore, my a is 6 times 3, which is 18. Okay, now part B. Find the sum to infinity of a geometric progression is 9 times the sum of the first 4 terms. Given first term is 12, find the value of the fifth term. So now, for geometric progression, sum to infinity is 9 times sum of the first 4 terms. And given a is 12. Now, sum to infinity, let's say the r is, common ratio is r. Right? So the formula for S infinity is basically a over 1 minus r. Sn is a bracket rn minus 1 over r minus 1. Then from here, I will just direct substitute into the formula. My a is 12 over 1 minus r equals to 9 of a is 12. Then r degree n is 4 now. So replace the n by 4 minus 1 over r minus 1. Okay, then from here, I notice that I have 12 both sides, so I can cancel off 12. Right, then now to get the fifth term, before you get the fifth term, you need to get the r first. So then from here, and I also notice that 1 minus r can be cancelled off. So once you cancel off, basically the left hand side left 1. Alright, so here I will write 1 equals to 9 brackets r degree 4 minus 1. So 1 equals to 9r degree 4 minus 9. So then the minus 9 will be moved to the other side, becomes positive 9. So I'm getting 9r degree 4 is 10. Therefore, my r degree 4 is Okay, let me check. Oh, sorry, I overlook it. This is 1 minus r, this is r minus 1. So basically you cannot cancel like that, right? So I miss out. Okay, sorry. This formula shouldn't be r degree 4 minus 1 because we know that as infinity exists, that means your r modulus r must be less than 1. So when modulus r less than 1, our sum to infinity, our sum to the first n terms will not be like this. It will be 1 over a bracket 1 minus rn over 1 minus r because of this. Okay, now sorry about that. So it will be 12 bracket 1 minus r degree 4 over 1 minus r. Then now you can cancel off the 1 minus r because both are the same. And same goes to the 12. So the 12 can be cancelled off. Alright. So then from here, you will be getting 1 on the left side. And then 9 brackets 1 minus r degree 4 on the right side. And now, again, before you get the fifth term, I need to get the r first because I know that the a is 12. So here 1 equals to 9 minus 9r4. So 9r4 move to the other side to get positive. Then this one move to right side. Therefore, I will be getting 8. So here, r degree 4 is 8 over 9. Now, leave it first because we need to find fifth term. So fifth term is basically ar degree 4. So no need, no need to find the r degree 1. This is 12 times 8 over 9. Now, just for information, for GP, geometric progression, the n term is ar degree n minus 1. Excuse me. So from here, you will be getting 32 over 3. So that's your fifth term. Okay, now move on to question 11. The diagram shows parts of the curve. So this is a curve and the minimum points M. First part, find expressions for dy dx and the integration. So now I will write y equals to square root of 4x plus 1 plus 9 over square root of 4x plus 1. And then here I will change to 4x plus 1 to degree half plus. So the square root in the denominator will be moved up. 9 bracket 4x plus 1 to the power of negative half. So this is my y. And now I need to get differentiation, the dy dx. So our formula is d over dx fx to the power of n, that is n times fx to the power of n minus 1. Then you differentiate fx, that is f prime x. So which means my dy over dx, I have to move down the half, rewrite the function. The degree instead of half, now you minus 1, that is minus half. And then don't forget to differentiate the bracket. Okay, the function inside the bracket. So you will be getting 4. Then plus 9, bring down the negative half. Then 4x plus 1. So negative half minus 1, that will be negative 3 over 2. And then differentiate the bracket, that is 4. Okay, so from here, just simplify the terms. So then look at here, the half and 4 becomes 2. Simplify. This half and 4 becomes 2. Okay, and for the first term, I'm getting 2 over square root because of the negative degree. So 4x plus 1. And for the second term, do not forget this minus. So minus and plus is a minus, right? So this 9 and 2 will be 18. So I will write 18, but it's minus 18. Then power negative 3 over 2. So I will just write over square root of 4x plus 1, then cube. Okay, so that is my dy dx. Now for the integration, refer to this form and integrate. Now our integration formula, ax plus b, you integrate ax plus b to the power of n, that is ax plus b to the power of n plus 1 over n plus 1. Then differentiate ax plus b is a. Then after that plus c. Remember, this formula is valid when the n is not minus 1. So now again, when I do integration, integrate y dx, that is integrate 4x plus 1 degree half plus 9 bracket 4x plus 1 degree negative half. So when I integrate, use this formula, rewrite the whole function. The degree instead of half now becomes 3 over 2 because you plus 1. So 3 over 2 over the new degree 3 over 2. And now we differentiate the function inside the bracket, that is 4x plus 1. So when differentiate, you are getting 4. Okay, so for the second term, rewrite the 9, rewrite the whole function. Now your degree minus half, you plus 1, that is half. Then over new degree half and differentiate 4x plus 1, it is 4. After that, plus c. And now here, I will simplify. The 2, the half and the 4 becomes 2. Simplify into 2. Okay, so here, same. Therefore, I will be getting 4x plus 1 to degree with degree of 3 over 2, then divided by 6. And plus 9 bracket 4x plus 1 to the power of half divided by 2 followed by plus c. So that is my integration. Okay, now part 2, find the coordinates of M. So now let's look at the graph first. So the M is basically minimum point. So whenever you see minimum points, that means dy dx equals to 0 because it is a stationary point as well. So now I will refer to my dy dx, which means this form. Okay, and let it be 0. So now I will write dy dx equals to 0. That means 2 over square root minus 18 over cube of the root. Cube of the square root. 2 over square root 4x plus 1 minus 18 over cube of this equals to 0. Okay, so now what to do is you just make it to the same denominator. So I make it to over square root 4x plus 1 cube. So it means that for the first denominator, for the first term, I need to times 2, then degree 2 of this square root. Okay, then minus 18 equals to 0. Now, the right side, the denominator, when you move up, it will be 0 as well. Okay, so this one, when I move up, it will be 0. So it means that I will just solve the numerator. So it means 2 square root 4x plus 1 squared minus 18 equals to 0. Then now, 2 square root 4x plus 1 squared equals to 18. And now I divide by 2. So when I divide by 2, I'm getting square root of 4x plus 1 squared equals to 9. And now here, square and square root can be cancelled off. Okay, so I am getting 4x plus 1 equals to 9. Therefore, 4x equals to 8. Hence, your x is 2. And now the question asking for coordinates of M. Now, for the coordinates of M, I need to find the y. Therefore, I will substitute back into this y expression. So, I will write here, my y equals to square root of 4x plus 1 plus 9 over square root of 4x plus 1. That means when my x equals to 2, I will get y equals to square root 4 times 2 plus 1 plus 9 over square root 4 times 2 plus 1. That is going to be square root of 9 plus 9 over square root of 9. That is 3 plus 9 over 3. That is 6. Okay, then here I will just write my m is basically with coordinates 2, 6. Okay, now the shaded region is bounded by the curve, the y-axis, and the line through M, parallel to x-axis. Find, showing all necessary working, the area of the shaded region. Okay, let's look at the graph first. Right, basically, I know my M with coordinates 2, 6. So means here 2, and this is 6. Right, and it's mentioned that this is 90 degrees. See here, 90 degrees. So what I need to do is to get this area of the shaded region, I will just integrate this graph from 0 to 2, means I'm finding all these regions. Okay, the area of all these regions. Then I have to minus this rectangle. Right, because it's mentioned here 90 degrees. So I know that this is 6, the height is 6, and then here is 2. Alright, so I integrate this. My area is integrate y dx. So we have done the integration just now. Right, I just need to add on the limits from 0 to 2. Then I minus the rectangle. Area of rectangle is 6 times 2. So I will just write down the formula first. My area is integrate 0 to 2, the y, right, y dx, then minus 2 times 6. So now my integration already done, which is this expression. So I will copy this and add on the limits. So when you copy this, do not copy the plus c, because now with limits we do not write plus c. Alright, so here I will just copy. Then I will write that is 4x plus 1 to the power of 3 over 2 over 6 plus 9 of 4x plus 1 to the power of half, then over 2. I get it from the first part. Then minus 12. Then now replace the x by 2. So I will factorize the 1 over 6. So 4 times 2 plus 1 to the power of 3 over 2 plus 9 over 2. Again, 4 times 2 plus 1 to the power of half. Minus when the x is replaced by 0. Okay, substitute. So here 0. So when 0, that means left 1 over 6. Right, 1 to the power of 1 to the power of 3 over 2 over 6. Then plus, again here is 0. So 1 degree half. So I get 9 square root 1 over 2. Then after that minus 12. Then here is going to be 1 over 6, 9 degree, 3 over 2, plus 9 over 2. 4 times 2 plus 1 is basically 9. Then here minus 1 over 6 minus 9 over 2. Because this is square root. Okay, then minus 12. Then from here, you will be getting 9 over 2 plus 27 over 2. Okay, so these two terms, right, it will be minus 14 over 3. Or probably I will just write like that. Then minus another 12. Therefore, final answer is 4 over 3. That is your area of the shaded region. Okay, so I have completed this paper, right, and also comes to the end of the video. Thanks for watching. If you enjoy watching this video, please like this video and subscribe to the channel, and also share this channel with your friends. Alright, to show support to this channel, you may just click the thanks button below the video, and Thank you everyone. Bye.